My name is Joey Kappa. I'm a software developer. I've been a software developer for quite a few years now, more than I care to remember. And today I'm going to talk a little bit about how we try to replace, or in the process of replacing, our core platform, and kind of trying to do it without any of our customers noticing. So also, if you can read this slide, you get bonus points. So a little bit about me first, and a little photo on the left there when I had a lot shorter hair. I spent probably the last 5 or so years working in the space of payments and in financial technology in general. About 18 months ago, I moved to a company called Elliptic. I've been having a great time there. My day-to-day is often working with sort of really big data sets, and specifically looking at how we can deal with streaming that data in and dealing with errors and stuff like that. Outside of this, I'm really passionate about programming, and fortunately, unlike Vinod, I have a little bit more opportunity day-to-day to actually write some code. I'm specifically quite interested in functional programming, and I actually finished a PhD in functional programming about 5 or 6 years ago. So I'm going to promise not to chew you off about all the virtues of functional programming today, but we definitely do try and take the basics and apply them day-to-day to sort of make our code simpler and cleaner and easy to understand. So a little bit about Elliptic itself. Elliptic has been making so-called blockchain analytics tools for about 5 or 6 years now. We're based out of London, but in the last couple of years, we've seen quite a lot of growth, and we now have offices in the United States and in Asia as well. We have quite a diverse set of customers. So we have customers like big financial institutions, such as banks like Wells Fargo and Santander. We also help out law enforcement agencies. And if you've ever spent any time in the crypto space at all, you'll definitely know some of our customers, because we deal with some of the biggest names like Coinbase and Square. Our main objective is to try and help our customers understand and detect financial crime. And this comes in the form of providing them with intelligence about what's happening on the blockchain, what entities are out there, and how they're interacting with one another. And another part of our role is to try and help them achieve regulatory compliance. So these days in the US and the UK and across Europe, there's a lot of regulation around what you're allowed to do and what you need to check for, what risks you need to guide yourself against. And so depending on the jurisdiction, that can vary quite a lot. It's quite a difficult problem to solve. Here's a little screenshot for you from our current software, and just shows, for example, a customer screening a transaction from one of their customers and finding out that actually some of the money came from a terrorist organization, for example, or that's our claim. So I'm going to start by trying to explain a little bit about what blockchain analytics is first, to give some context, and then I'm going to give a whirlwind sort of introduction to how we try to solve some of the problems. It's quite difficult to explain what blockchain analytics is without first talking about blockchain. You've probably heard the term. It was a bit of a buzzword that kind of went around the industry 5-10 years ago, and positive or negative connotations either way. It does serve a very useful purpose when it comes to cryptocurrency and digital currencies. And I won't try and describe all the details today, but what I will say is that if you take nothing else away, just think of it as a public transaction ledger for a digital currency. And in this sense, unlike traditional networks, say the Visa network or MasterCard and stuff like that, or banks where their ledgers are private, Bitcoin, for example, strives to have a public ledger where events, these might be things like a transfer of funds, I might try and send $10 to one of my friends, that might be public and anybody can see it, but the entities involved, so who I specifically am and who I'm sending it to, might not be obvious. At Elliptic, we talk a lot about entities, and by this we really just mean identifying sets or clusters of addresses. Here you can think of addresses as being like account numbers, like with a bank, and grouping them together, clustering them, so that we can say we think all these addresses are owned by the same person. And so we can start to talk about how these different entities interact with one another. On networks like Bitcoin, which is one of the most popular cryptocurrencies, using an address more than once is actually discouraged, and it's pretty atypical to do. And so some of these clusters can grow really big, and we're talking tens of thousands, hundreds of thousands, millions of addresses, all being owned by the same entities, and it's not so obvious that they're actually transacting with one another or how the money is moving around. So we try and create tools that allow our customers to analyze what's going on. And specifically, we try to help our customers identify these entities. We try and take these sets of addresses and expand them to be as big as we can while still remaining within a reasonable level of confidence. And we try and label these clusters so our customers can kind of understand what's going on. So, okay, who is this? It's a company called Kraken. Well, what do they do? Or will they provide a legitimate service to change fiat money into digital currency and back again? And so that way, our customers can use this to sort of help them make decisions about what their customers are doing. For example, if a bank has recently received a transaction from Joe Blogs and it's come from the Bitcoin network originally, well, they might wonder, well, for the purposes of checking for money laundering or something like that, where did that money come from? Has it come from a terrorist organization? Has it come from ransomware? And this, you know, they need to do this as part of their due diligence. The way we achieve that is we use all sorts of methods. First of all, we have an excellent cryptocurrency intelligence team. They sort of spend their time scouring the web and doing research and investigating all sorts of stuff to do in the world of crypto and trying to assert addresses, basically saying we have, you know, really high confidence that this particular address belongs to Elon Musk. And obviously, we don't just go to Reddit and see a tweet that says such and such address is Elon's and stick it on our tool, but we build up an ever-growing body of evidence to try and become more and more confident that we can assert certain things are true on the network. And then on top of that, we layer everything from sort of simple heuristics that we know apply and generally apply to the network that allow us to cluster addresses together. But we also use some more sophisticated methods like machine learning and have pretty interesting data models to try and work out where the money's flowing to and who owns it at any given time. So you're probably asking yourself, what's so difficult about this as a problem? We're just sticking labels and addresses, aren't we? Or grouping addresses together? Well, actually, I would say that this list I've put here is quite a short one and you could make it a lot longer. But these three are the top three, I think, that we've been encountering in the last sort of 4 to 6 months as we've been trying to re-platform. And that is, first of all, there's a lot of different networks. So if you've heard of cryptocurrency, you might have heard of Bitcoin, you may have even heard of Ethereum, but there's a whole host. And Elliptic, we support many, many others, such as Zilliqa and Stellar. And each one of these networks is sort of subtly different from one another. So some of them support more than one asset, they might have a different protocol, and they all come with their own technical challenges. The second big problem is that some of these networks are really, really big. To give you an idea, one particular network that's only about 4 or 5 years old has about 3 or 4 terabytes of transaction data so far, and it's growing every day. And so certainly it's easy to imagine if you extrapolate that to the next sort of 5, 10, 50 years, if it keeps going, you know, that's going to be a lot of data, and a lot of data comes in all the time. And thirdly, our customers often want answers right away. They want to be getting answers about transactions that happened seconds ago, not hours ago. And so with this data constantly coming in, it can be a real challenge to keep up with the tip, sort of the last block that was mined in the terminology of blockchain. And in order to do this, all these three things together, it's a really challenging problem. So I'm going to describe a little bit about the software project we've been undertaking for the last 6 months or so. And to do that, I need to talk a little bit about where we started. So right now, we have a fairly sophisticated piece of software. It's, does its job really, really well. But the main issues with it is that it processes stuff in batch. So every couple of hours, it takes a snapshot of the whole blockchain, it does some processing, and then it gives that result to our customers. Of course, the big problem with this is that our customers need answers right away. They can't be waiting hours. They need, sometimes they need answers within seconds. The second issue is that it assumes a very specific network architecture. So it really is built to serve Bitcoin and Bitcoin-like networks. And when we came to support Ethereum originally, we actually found that we needed to build so much stuff again from scratch. It was so time-consuming that the cost of adding a new network was just really, really high. And the third problem we had with it, and this was probably the real killer, is that it was a piece of software that was designed as a Java monolith. Not that there's anything specifically wrong with that, but it meant that it sat on a single box. It consumed a huge amount of memory. And every time the network grows a little bit more, we find that we have to make the box bigger, and it really didn't scale. Like, we're talking about running specialized boxes with hundreds and hundreds of gig of memory to just to do a single step of processing. And this was completely untenable. So where do we want to be? Well, we wanted it to be real time. We really wanted it to be sort of network or asset agnostic, so it didn't depend on specific blockchain or have any details that were specific to one. And we wanted it to scale horizontally pretty much forever. And that's to say, if we add, if the data goes up linearly in scale, well, we want our prices and costs to go up linearly in scale. And we want the size of the boxes or whatever we're running to go up linearly as well. And probably the last point, which I think it really has been the central challenge for us, is we wanted to write as little code as possible here. We wanted to move really quickly. We wanted to take stuff that's already been built out of the box, glue it together, and have a system. And we didn't want to spend our time writing the sort of unexciting code. We wanted to be writing the exciting code, that is the stuff that solves our customers' problems. So the next couple of slides, I've put a couple of diagrams. I don't expect you to look into them with any depth or really understand what's going on, but I've put them there because they're a good indication of roughly sort of some of the structures we ended up with. First things first, we found that we needed to transform all the data into a common format so that we could process it and manage it the same way. And in particular, a lot of these networks are very event-driven. So a new transaction would get confirmed on one of the networks. I sent my friend some money. At the point at which that happens, we wanted to deal with it as quickly as possible. And so to do this, we've really, really heavily leaned into using AWS Lambda. But serverless compute is really the hero of the story, in that, you know, some of these networks don't see very much traffic. And so for those, maybe there's a new block every half an hour. We just run a handful of Lambdas every hour. But some of the networks are extremely busy and have a huge amount of traffic on them. And for that, with the exact same code, the exact same infrastructure, we were able to spin up thousands and thousands of Lambdas per minute, sometimes thousands of Lambdas per second to deal with the throughput. And this was really, really powerful. The second important component was using Kinesis. And Kinesis is just a managed data stream. And I think the important thing here is, there are lots of streaming platforms and technologies out there that are available. Certainly if we went with something like Kafka, it has a much richer feature set. But the great win with Kinesis is, first of all, it's managed. We didn't have to sort of spin up any boxes, keep an eye on how much memory they're using, anything like that. There's just some simple configuration that you can tweak to get it to work the way you want it to work. And then from that point on, we're talking half a day, we were having some of these streams up and running with data on them that was useful. And of course, one of the great reasons to use something like streams like Kinesis is that we can have lots of different consumers. So in our particular example, we had some really, really big jobs that would take hours to run still. And for that, we could just archive off the data to S3, and then we use Spark to process it. And for the stuff that was actually we needed to deliver in real time, we just stuck some more Lambdas on top of that stream and processed it in real time. So another diagram on the left. Once again, don't read into it too deeply, but the main theme is, we kind of went all in here on serverless, and so we use a lot of Lambdas to process a lot of data, but we also opted to use a database, a persistence layer called Dynamodb, which you may already be familiar with. But the key point to take away here is it's another instance where we're not spinning up boxes, we're not managing them individually, and most importantly of all, it scales horizontally pretty much forever. And this is great for us because the amount of data we're going to be gathering is pretty much unbounded over time. Like if we take on another big project for a big blockchain network, that could be 3, 5, 10 terabytes. And we wanted to be able to just drop it into the same database and not have to worry about running out of memory or anything like that. A particularly interesting pattern that I think we used is because DynamoDB is a key value store, we needed to denormalize all of our data so that we could store it efficiently, basically, and look it up efficiently. This was a difficult step to achieve, but we are there now, and it's ended up meaning that we can do sort of single-digit millisecond lookups and queries across many, many terabytes of data. And the data is fairly heterogeneous as well. And there's even a nice little pattern that we found where we could use these so-called DynamoDB streams. These are very similar to the Kinesis streams. You can think of them as a sort of change feed on the data. And we could just stick more Lambdas on them, listen to changes, do more processing, apply more heuristics, and aggregate more data that's useful for our customers' queries. And on the query side, we actually just stuck with a fairly conventional always-on service that sits and is able to sort of prod these Dynamo tables and run queries and answer our customers' questions. So it sounds like it's all fun and games using serverless, but there definitely was some teething points and there's definitely some problems. I think the biggest one for us was having some observability over the platform. In particular, if you think it's a difficult challenge, logging metrics, logging application logs, having tracing through your system for a couple of microservices. Imagine how hard it gets when you have hundreds of different instances of Lambdas running thousands and thousands of times a second, interacting with queues, interacting with DynamoDB and databases and so on and so on. So we really put a lot of energy and investment into this side of things once we'd got the core platform sort of roughly sketched out. And we've put a lot of time into sort of ingesting these logs and metrics and tracing into tools like Datadog so that we have a really good picture of what's going on. The other big downside with scaling forever is that your costs also have a habit of scaling forever if you're not careful. So we did need to be very careful to add some sensible limits in places so that we didn't wake up one morning and find out one of our customers had, increased their request throughput by a factor of 1,000, and all of a sudden we had a bill going through the roof. And I think the final thing to take away from it for us was that, serverless wasn't a silver bullet, but then neither is serverfull. And really, you get the best of both worlds when we combine the two. And we found this in particular with a lot of our services that do querying are serverfull and are always on and listening to our customers' requests. But a lot of the backend is event-driven and runs off of Lambda. That's all I probably have time for, but I hopefully have time for a couple of questions. I don't know if there's any questions.
Hey, Doi. Thanks for fascinating talk. Like one of the questions like I would have for you is like how what's been happening in the sort of last year, like Bitcoin hitting a lot of headlines and generally becoming more and more mainstream with some household names entering the space. How is that impacting? Like how do you keep balance between what you're doing now and what's needed now, and what are you planning for in the next 2-3 years? So in other words, like how are you kind of like prioritizing what's needed now and long-term vision of what might become a reality in a month, year or so?
Yeah, that's a great question, and I think you've identified that in the last, I don't know if you follow Bitcoin, but in the last sort of 6 months to a year, the price has really shot up, and with all that extra activity, like everybody and their grandma's buying Bitcoin now. The amount of throughput we've seen from some of our customers has also shot through the roof, and that's been really challenging. We've had to sort of adjust some of our SLAs. We've had to deal with high load, and it's been a real incentive to get on with working on this platform in production. But I guess the question you're asking is how do we balance that with things like also adding new features for our customers, because that's what they need. And I have to admit it's been difficult. I think part of it is trying to move quickly and trying not to get bogged down. A lot of the wins we've had have been because we've said, we're going to pick this technology. It's relatively expensive to run, but it's fully managed, and we're not going to spend 2 weeks of developer time doing DevOps. It's something that we're paying the cost for up front now. And maybe a year from now, we'll be able to take a step back and say, right, we're more comfortable where we are, and we can replace Kinesis with a cheaper alternative or a more specific alternative that does something more cost effectively than what we're doing. But right now, we're really focusing on growing, and we've grown a lot in the last year, and I think there's been a huge surge of interest in crypto as well in the last year, and it's a challenging space to be in for sure.
But a fascinating one. Okay, a couple of other questions. Like Abu Adon is saying, great presentation. How do you handle unexpected spikes? Manually trigger more lambdas?
This is a good question, and we actually had sort of not quite this. We had the reverse of this, where we had a huge spike, and recently, and we didn't have any bounds set. This was actually what I was talking about at the end with these unbounded costs. The great thing about a lot of this technology is it will scale for you. So we were running, for example, a couple of 100 lambdas per second for one of our networks. And this was going really, really well until one of the networks had a sort of issue. And for whatever reason, we ended up failing. And because of our retry logic, we ended up running thousands of lambdas per second. And this put a huge load on DynamoDB. Now, the great thing about Dynamo is you can scale it forever. But if you scale it forever, it costs quite a lot. And we ended up spending a lot of money over a weekend that we wish we hadn't. But the upside is, we learned from this lesson. We added some alerts in. We added some upper bounds for how big it will scale. And we managed to keep our costs sort of within reason. But on the other side, with it not sort of scaling up fast enough, we've had very, very few problems there. I think the only real issue we've had is with Dynamo not scaling fast enough in some instances. So where the customer demand really spikes, and we're talking orders of magnitude within less than a minute. Occasionally we've been sort of not hitting our SLAs with regards to returning 500s and stuff like that, and that's definitely an area for us to look into and see if we can find some sort of solution that provides a stopgap while we can't even scale aggressively as aggressively as we'd like.
Yeah. And one more question from Francesco. Can you expand upon your choice between Kinesis and Kafka?
Yeah, I think this is, we could probably talk about this for quite a long time. At a previous job, I used Kafka quite extensively, and it offers some really, really incredible features that you just don't get with Kinesis. To name but a few, log compaction, having a schema registry, having a lot more partitions, and the cost of partitions being a lot lower for a particular stream. And these are really big wins for Kafka. But for us, we've had experience in the past of setting up a Kafka cluster and managing a Kafka cluster, and it is expensive. And it is time consuming, and it's a heavy burden on DevOps if you're not willing to sort of go with a third-party provider, which of course brings its own costs. By comparison, something like Kinesis, if you go into the AWS console and just click create a new stream, you can have a new stream up and running in 5 minutes. You can have it archiving to S3 in another minute. You can start running analytics over it with Kinesis Analytics in another 5 minutes. And if you're at the stage of the project where we were 2 or 3 months ago, this was a huge win, going from essentially nothing to having a really, really rough proof of concept within a couple of days. And I don't think we would have been able to achieve that with Kafka. Now, am I ruling out Kafka in the future for us? Probably not. But today, Kinesis definitely sort of provides everything we need to.